All right, I guess we're right on time here. I'm just going to go ahead and get started. So this is Working with PSGraph. I'm your host, Kevin Marquette. After the session, I do have more stickers. So if you guys are interested, hit me up afterwards, and I'll hand a few of these out. So I guess, why am I talking about PSGraph? Well, it's actually my module. I built this thing, so I figured nobody should be more up to speed on this thing than myself. I've actually presented on various pieces and aspects of this module to various user groups. So if you've seen one of those sessions, there might be a fair amount of overlap, but I've got quite a bit refreshed specifically for the summit here. And then I'm actually using this module in production. So, I mean, it's not like mission critical for servers going down or anything, but we have workflows that as they go and interact with the business, we pull data and generate graphs from that data, and it's part of the way we do business. So what kind of graphs am I talking about here? I'm talking about like node-to-node based diagrams. Something that's like relational or showing dependencies or structure in data. So like behind me, I've got like a file folder structure showing tests or maybe processes, and which process has a child process as a way to like see these relationships. So it's like kind of like Visio, right? Except you can automate it and do it via PowerShell to build these diagrams. And I've always been a fan of seeing stuff in a visual way. I've used Visio quite a bit. I've just never found a good framework that I liked to automate diagrams from data in Visio. So I turned to some other tools here. And PSGraph itself is a PowerShell module that's implemented as a DSL, which kind of means I built some like really friendly commands that use language very close to graphing information. So like the example behind me, I'll go into a little bit more, but I'm defining a node, like the list of nodes that I want rendered, and then I'm saying I want an edge from the start to the middle and an edge from the middle to the end. And then I actually pass all this off to a rendering engine called GraphViz, which is actually a pretty popular open source tool for building diagrams like this. So what I'm really doing is just making it really easy to work with, especially if you're in PowerShell, to do more complex diagrams. So let's take a peek at some code here and see what we can graph today. I knew it was going to do that. Excellent. All right, so getting started with PSGraph, like out of the gate, I mentioned I'm depending on GraphViz, and I think one of the easiest ways to get started with it is to install it from Chocolatey. So GraphViz is a separate library executable that you have to install. For Windows, this is the path, or an easy way to install it. If you're on Linux or Mac, you'll have to go to GraphViz.org to find the download for it for your platform. So with that said, this module is cross-platform. It will work on Mac OS and Linux. Just the installation of the GraphViz engine is a little bit nuanced. But once you're up and running with it, we can do all kinds of fun stuff. And then my module's in the gallery, so you can do find module PSGraph and install like you would any other module. So let's go ahead and import this module. And we've got a small list of commands here, and I'm going to walk through these a little bit more closely. But I have lots of simple commands describing types of things that I'd want to graph, and with a few helper functions to help us out along the way. So looking at our features, so this is that very basic graph I had on the slide. Right? I'm defining 3 nodes and drawing edges between them. As a DSL, my graph here is saying, here's the contents of my graph. And I'm actually piping it out to this helper function to actually make the graph pop up so we can take a peek at it. So when I pipe this entire thing to show PSGraph, we're going to get the exact diagram I've kind of described and explained using this DSL. So just to break that helper function down a little bit more, it's kind of basically saying, hey, I've got this file I want to save, this image I want to render, and I can actually export this graph directly to a file instead of like showing it on the screen. So if you have some sort of process or pipeline that's nobody's actually looking at it, it could just be automatically generating these and firing them off and saving them to whatever location you want to specify your image to be saved to. So I need to run this line here. And then I'm going to open this up in VS Code. And I'm just going to pin this guy over the side. So I'm going to save over this file multiple times throughout this demo. Kind of do this like a preview on the right as we're going through some of these diagrams. Okay, so edges, right? These are the lines between nodes. And one of the nice features about PSGraph is that I don't necessarily have to define a node in order to draw an edge to it. So if I just say, draw an edge from like first to second, actually let me just go and render this guy so you can see it as I describe it. And this first one, like I'm basically saying, hey, I'm going to draw an edge from the first node to the second node. And it's smart to realize, hey, I actually got to draw this node if I want to draw an edge between it. So, and same in the second one here is like, I had this, I try to keep this syntax as user-friendly as possible. So if you want to be verbose, saying from first to second, you can be very verbose. You can drop off the from to say, just edge from third to fourth. And if you actually provided a list of things, like an array of 4 items, it will actually draw lines between all 4 of them in a row. And that's kind of what this one here on the right is the edges from 5th to 6th to 7th to 8th. Then my edge command also supports some multipath featuring. So if I run this item here, I can actually say from the first node A, draw a line to all 3 of these nodes. So we'll do 1, 2, and 3. And we actually like this dot product, cross product, where I say, I've got these 2 items that need to connect to all 3 of these items. And that's what we saw over in the far right is it actually drew all those connections for me. So I know it'll get crazy fast if you have lots of cross connections. It might be hard to read, but sometimes that's exactly what I'm going to describe. I want to make that easy for you to draw that type of a diagram. So, oh yeah, and then we got attributes as a way to make put a little more style into your graphs and edges. So here I'm doing my same first to second edge, but I'm giving it a hash table of additional properties to apply to this graph. So in this case, I'm adding an additional label to this edge and giving it color as a way to maybe differentiate or have some special meaning behind those. The node syntax, like if I just need a node sitting on a graph without any edges, I can call it out explicitly, just saying, hey, let's generate 4 nodes and put it on a graph. But building on that, you can actually start adding attributes and labels and more custom properties to these by using the node command. So in this case, I've been showing just the ID. Like first is like the node name, but there'll be times where your IDs for data and the names won't necessarily align. And so you might want a friendly name on something. So here's a case where I can have something with a nice friendly name on the graph, but I can use this simple identifier when I'm doing my graph in PowerShell. And this might be one of those cases where I'm mapping from, like, say, an employee username might make a good ID, like doing managers or whatnot, but you want to render it on the graph as showing their friendly names. And I'll show some examples later on that highlight that a little bit better. And there are lots of options and lots of ways to customize both edges and nodes. So if I want to do pretty pictures in PSGraph, I wouldn't recommend it, but I have all of these options available to me to tweak, the style and the color and whatever else. And then graphs themselves support attributes. So I have a hash table here as well. I'm going to unroll this just a little bit. So if I actually want to put a label on my graph and change the direction and flow of it, I can use this syntax here. So now it's going, the ranked direction is from left to right versus top to bottom, and the label now shows up on the graph. So if you need footers or header information, that's one way to inject it. Now, there is a ton of attributes available, and I'm going to refer you to the GraphViz documentation. Assuming I have network connectivity and this opens up, the point is more that I'm not going to really show you many more of these, just that there is a lot of them. So if you want to customize stuff, definitely refer to the GraphViz documentation. And I actually tried to stay very true to the GraphViz language. So all these attributes that are available to GraphViz, I've exposed as available through PSGraph. And the reality of it is, PSGraph itself is just concatenating a whole bunch of strings and kicking it over to GraphViz to actually do the rendering. So I tried to keep this as true to their language and syntax as possible. And that's why we're able to specify any of those properties in the various hash table locations. Okay. And then the last thing in attributes is you can actually specify defaults for the whole rest of the graph. So in a case where I don't want to say each one of these needs to be a box or the color needs to be red for every single item, I can call a nameless node or a nameless edge with some defaults here. And then everything later on in the file will basically use those defaults. It is a top-down processing. So if you actually have like a really giant graph you're doing, you actually start with a set of defaults at the top, do a half dozen things, and then create a new set of defaults for the rest of the graph. They will override previous ones, but they won't like remove some that you've predefined. So if I had like 20 properties at the very top, I'd have to like overwrite all 20 of those to truly change that. But useful to know. Okay. So that's the core of GraphViz and the language. But I've got lots of other features that I'm starting to build on top of those basic building blocks. So the really nice thing about automated generated diagrams and graphs is that they're automatically diagrammed, right? Like you don't have to do the work to lay them out and position anything. But the frustrating thing is they're automatic and you don't get the chance to do the layout and positioning of them. So you kind of have to do that give and take of, I can't always make things look exactly the way I want because I'm doing as much as automated as possible. There are some things that can help with that. The rank command will identify nodes that should be at the same level. So let me draw this diagram once here. And we'll see how we get these two flows, right? The first, second, third, the fourth, fifth, and sixth. And for some reason, I want to have the second, sixth, and the fourth in like the same horizontal line. I can rank them equally together. So putting them on a rank will allow them to instruct the engine to actually line these things up this way. So there'll be times where I actually use this quite a bit to make sure the things have that alignment that I'm looking for. Subgraphs. Sometimes you need graphs inside graphs, and with subgraphs you can do that, which generally turn out to be like a box, a way to basically have a sub-collection or a grouping within the larger graph itself. I will say, though, just from making heavy use of this, is that there are many times that I felt like I really wanted a subgraph, but they tend to like constrict some of the flow of things. And the more complex my overall graph was, having too many subgraphs in there actually became more of a hassle than it was worth. But in the simple diagrams, when you want the subgraph, don't hesitate to use it.
I have made a subgraph as a legend of what the shapes means and such.
Yeah, so like here I'm doing the graph of everything together, but you could actually do a subgraph that's like a legend that has specific features and diagrams of the attributes that you're using in the rest of it. Like here, I'm letting stuff cascade and flow across the subgraph, but you could have multiple subgraphs on a single graph that have no actual connections to each other.
Can the subgraph be ranked?
You'd have to experiment with it. I think you start ranking with subgraphs. I think it's one thing you have to play with until you got the look that you wanted. I do have the feature to draw edges from subgraphs to nodes. So here's a case where I have this group 1, the subgraph draws an edge to this 5th node here. They aren't always as pretty as I want them to be, but it is a feature that I saw that need for it, so I added it in there. The underlying GraphViz syntax is really ugly for that, but my syntax makes it a lot easier to work with. And then records is a new keyword that I've introduced that will let me take a list of things and put them in this nice, clean little table of items. So we can also draw edges from row to row. So by just doing an array of strings, I get this table. But if I actually use a row keyword to say this is a row, I can give it a name. If I give it a name, I can draw, I need to reduce my font slightly here. I can draw an edge to it. So here, I'm basically able to draw an edge from the various rows within the graph to point to each other. So as you start thinking of like class diagrams or something like a database schema, you might want to have relationships. And that was such a common pattern that I've added this little entity keyword that will allow me to graph like a PS custom object to see what it looks like just as like what the structure of it is. And I have an alternate view here that will actually let me put the values in there. So I can actually I can just create an object and toss it in here and have a nice little table without having to create the rows and the records and the properties myself. Okay, so that covers the features of it. Now let's look at how to actually do something more useful with it, right? Let's put these features together and let's diagram some server infrastructure, right? So taking a simple idea of a multi-tier application and, all right, so here, I've got something that's like, I've defined my load balancer with one shape. I've got my nodes, the web layer, the API, the database, and the connections between them. I could probably do this in Visio as fast as I could do it here. I think as we start making this stuff more data-driven, like let's say we have arrays of things, right? So I have several nodes in the web tier, several nodes in the API tier. So it's going to be like almost the same diagram. And here's that case where through my web tier, that cross-connection, any web server can talk to any API server. And that's like one case where I might use this, array to array edge mapping. So this is PowerShell. We can use variables, right? So what if we just had this data set of web servers and API servers and database servers, and I use those instead? This diagram actually looks just like that first one with a very easy syntax where I'm saying, hey, there's my web servers and here's my API servers, and here's the connections between the web servers and the API endpoints, and it's doing a more complex diagram that now you can read it in this nice clean language because you put all your things in a variable, and this is very pleasant to look at as a way to describe something that can get more complex. But we don't have to stop there. Let's pull this data from a data source instead, right? Like, what if you had, like a CMDB or your SCCMD, like pull information into like role-based stuff into your data set. Here I'm just pulling it from a CSV. If I run this, I've just got several web servers and API servers and some IP information, which I'll use here in a second. And then I'm just doing some fancy filtering here to dump them into the same variables I used before, which let me run the exact same graph that I used before. But I don't want to do this quite yet. So let's dump that out just to show. All right. And it's getting bigger and bigger because I'm actually adding more nodes as we go. Like, I can just easily add a line to that spreadsheet now, and I get a new node in that layer. Or I can delete something and it disappears when I generate the graph the next time. And then by putting this logic in here again, because this is just PowerShell, I can actually just for each loop over my servers and call my node, specify the name, the computer name. I'm giving it a label saying the computer name and the IP address, and the /n is the syntax that GraphViz likes for new lines. So when we're running the same thing again, we get in our diagram like the IP addresses of this information. And you can keep adding more as you want your documentation and diagramming to kind of grow from that. Well, because this is PowerShell, we can kind of keep going with this pattern to do some like real-time service checks when I run the graph. So here I have some internal function that says, get test server connection to see that the server is alive or not. So I'm going to load that real quick. And this last graph, I'm kind of going to do the same thing before, where I'm going to do a for each for every server, run a test, determine, hey, if it passes, I'll do the color green. If it fails, the color red. And then down below here, I'm going to style it with a filled-in color based off that status. So now I'm doing this like real-time graph using PowerShell. It's saying, oh boy, we got some bad nodes over here. And let me just run that again. So like I can real time check the status of stuff, and I don't know what's wrong with their infrastructure, but I got a very clear picture that this problem is just jumping all over the place. I was like randomly like 20% were failing is what I was doing there. So okay, so that's really like kind of like a structure to the data you want, right? But what if we have like even more dynamic data, like an organizational chart? So here's where I'm going to grab this org chart from a CSV. And then we're going to just take a peek at the data. And my structure of my data is I have an ID for every person and their name, and a property that's their manager. So this is how I can actually map to know who reports to who in the organization. Using that information, I want everything to be a rectangle, because rectangles look better than the default ovals, and I probably use rectangle or box all over the place as a good default. So for every person, the name of the ID, so I'm using the ID as the identifier. The label, I'm putting the name in there so it's nice and friendly, and I've got a title, so let's toss that in there as well. And then I'm doing a second loop where I take all the people. Where there's a manager, since the CEO had no direct report, it was null. So I'm kind of in a way skipping the CEO. And for each object, we're going to draw an edge from the manager to the identifier. And man, that's just easy to see, read what's happening there. From manager to ID. So when we run this data set here, take a look at our diagram. We've got the hierarchical data that by looking at that table, it might have been necessarily easy to see, that structure just doesn't jump out at you. Like when you actually graph this thing and take a peek at the actual data, let's minimize that. As I look in here, I'm like, oh man, they're very management heavy, aren't they? It's like no staff compared to all the C-levels. So I couldn't see that from the table as easily as I could from this diagram. And the real point here is that the data, the structure of the data, if you can get something that has, I want to tab there, like back this data set real quick. The real beauty of the process is if you have a line of data and you have a column that relates to something else using the same data type, like the manager is an ID. It's using the identifier in this case. And if I actually have an ID on the same row, that's what I want to use as the node identifier. Because then I could just point those two at each other, and it knows it'll find it. Like, I didn't want to use the name as the ID, because when I'm trying to say point this manager to this name, I'd actually have to go find the row to find the name to say, from manager to manager based off the name. Like the ID is this natural relationship. So if there is a natural relationship in your data, try to use that as your primary ID to do those relationships. But I will say, because this is PowerShell, you could do some lookup and fancy logic to actually query to figure out something if it's not there. Then I do want to show, let's see, another feature. Since I use this pattern so often, like having this object that knows who he's related to, such a common pattern, I added an advanced syntax here that I can actually give my node the whole list of people, give the whole object, the whole CSV, and I got this node script that says, run the script for each one, and this will tell me what ID to use for that row. And then in my hash table, I kind of support the same thing. For each property, run this script. In this case, I'm saying, format the name and format the title for each one of them. So this, and then I kind of do the same thing for the manager here, where I filter the managers first, and then I say each node. I'm actually going to just wrap this slightly just so we see what it looks like. Dreaded backticks. So here's the same thing where I say, here's all my nodes, this has manager table, and use this script on each one to say, use this script to figure out who the manager is, or use this script to figure out who the manager is, and use this script to figure out who it's going to. And this graph is the exact same graph as the other one. It barely flashes over there. And it saves me from doing the for each object loop here. So, it's PowerShell if you could be comfortable, super comfortable doing the for each object loop. But when I'm doing lots and lots of graphs, I found that, having this shorter way, this more condensed way to describe what I want to draw these edges on, I kind of leverage that quite a bit. So don't feel like you have to use that more advanced feature, but it's a tool you can use that if you're doing this quite a bit, you're like, I feel like I like this line better than the previous line. And like I'm really doing script blocks to define those mappings. So, all right, so let's do some more demos here. Parent and child processes. Let's go and close this preview for this one. So here I'm basically going to ask my local system for all my processes, right? Get some instance process. And then let's take a quick peek at this. I got it formatted so I can actually see the process ID and the parent process ID. Like here's one where I've got a very similar identifier, right? So using this, I can figure out who belongs to who. So in my current system, we run this. And oh boy, look at that. And we just drill into something here. Like, here's VS Code and all of its processes. No wonder it sucks so much memory. I got PowerShell down here, which is actually launched Chrome, and there's all the Chrome processes. And this is because I actually launched it from my VS Code shell. And it's just interesting being able to see your system, as this mapping of who relates to what. And I can see Slack up here as well. Man, he runs a lot of processes as well. I have some of these that don't have a label on them, and they happen to be like processes that kicked off a process and have finished. So if I do a get process, he doesn't exist right now, but the child processes still say this is my parent. So in a way, they have no labels to override what that default was. And looking at the code, I'm using my fancy syntax where I'm saying for every process, use the process ID as the as the node name identifier. And the attributes, the label should be the process name. And the from script is process ID to, or parent process ID to the process ID. Network connections. So basically, as I was doing these demos, I'm trying to find data that's like natively on my system, and let's try to graph it. So I was like hunting for demo use cases, and these are kind of the ones that were easy enough to find, and you could run on your local systems, given the same demo here. So, you know what? Let's just flip over. Let's see if I totally destroy things here. So GetNet TCP connection is not available on PowerShell 6.2. So can I just run this guy? All right. Tempting fate here. Ah, there we go. So here is my system right now, and here's all the IP addresses I'm currently connected to. And you know what, I even added on here the ports that it's connecting on. So I've got my local port and my remote port. And this is data that just, I just don't have an easy way to see this anywhere else. Like I can't even tell you what tool I'd use today to find this clean of a graph to show me this is what my system's talking to. And it's data that just, yeah, loopback. So
And they're all looping back, so that makes sense.
they're successfully looping, yeah. And for every connection, there's a line. So there's multiple connections to multiple things here. And the logic on this one is, I don't even have any nodes on this one. I'm just saying, I had to splat this so it looks even more funny. But I'm saying, for my nodes, just give it the whole netstat list from the local address to the remote address. And then my label for each row, we're going to do a format string in here. I'm going to say the local port on the left and the remote port on the right. And in just these 12 lines of code, I built this beautiful diagram of everything my system's talking to. Process connections. What was my? Let me run this again to figure out what my IP address was. Copy paste. 10.18.14.120. 10.8. Oh. 18.14.120. Was that right? Sure, I'll take that. Okay, so I'm basically going to combine those two now. I'm going to say, let's go get all my network connections and my processes. And then in this graph, so I'm going to, each process node, I'm going to use the ID as the identifier and the process name as the label. And then my edges, this one, for netstat, I'm actually going to call the owning process as the from script. And then we're going to go to a remote address. And I'm going to use those same ports in here. So we'll run this example. And now, I can see OneDrive is talking to this address. Slack is talking to this, actually these two addresses. And that's something if I was going to look for a tool to do that, I have no idea what it would be. PowerShell, I do it with PowerShell, and now because I can do it with PowerShell, I can draw that graph and that diagram. That kind of shows you the power of imagine things that you want to see visually, and the data that you have, you can build these mappings and kind of show these diagrams in pieces. So I guess, at this point, any questions so far? I'd like to be a good point to field some questions if we have any.
So on your netstat example, is
Yeah.
there a way to hold other metadata in the shape as well? Like if you know the destination IP address, could you get GeoIP information from that address?
Yes, you could.
Can you hide it in the object, but just display only the foreign destination address? And where would you keep that other metadata at? And how would you access
Well, so since, okay, so the question is, what if there's just like other additional data that you need to be able to represent and show?
Or like it would be like helpful to have like that GeoIP information, but maybe not exactly on the graph image itself.
Yeah.
Yeah.
So, yeah, so if there's other metadata but you want to hide it or not show it, one thing you can do is that this here is a script. So we might be able to do resolve, what, DNS name? Like you can actually run a command to pull in information. And here I'm just doing edges and nodes, but if I wanted my nodes to be a little bit more richer, I could actually loop the list of like IP addresses and add the information that I want either in the box or use a record here and still point to that. So there's, yeah, if you have the data there, you can display it. Actually, I got one other, let me jump to this here. I have a helper function module, PSGraph Plus. It actually wraps a lot of my demos into functions you can run. So I think if I run this one, he's actually doing NS lookups to see even the domain name that is resolving behind that. So here I'm actually going the extra step of, I know the IP, let me go query and pull and present those additional pieces on there. So if you want to try some of these diagrams and don't want to actually go through GraphViz to do it, this PSGraph Plus module has those baked into it. So some production examples. So like I said, I use it in my environment. And I'm in DevOps, and we're doing configuration as code, and we have this beautiful database that tells us everything about everything we deploy. Like I know from my data what services depend on what other services. And we built some helper commands to actually ask it and tell us, hey, who depends on me? So I don't have the code for these available, but I do have examples of the rendered images. In fact, I probably have to kill, let me get out of PS5 here. There we go. So each one of these is a deployable thing in my environment. This ABC core is a core service. And to the right is the downstream, is everything that we know it depends on. So if I'm troubleshooting this guy, I might want to look at the stuff downstream from him to see, hey, is this vendor thing working, or is ABC rules doing what it's supposed to do? And I can go the other way, is who depends on the service. Like if this guy's down, who am I going to impact upstream? This admin portal or this NOP core thing. Now, this is all normalized, so I don't know what these things really are, but yeah, here's an example that I took this one component, and actually the details on the bottom here. I said, give me the upstream 2 levels and the downstream 2 levels, and I was able to render and see that relationship. So when somebody's asking me, who does this talk to, I can go to this. And you know, we could do other things like that too, like firewall rules. So for our firewall rules, when we process the requests and get security to sign off on them, we generate a diagram like this. A little noisy, but it's basically just pointing that there's a firewall rule here we want them to approve, and a firewall rule here that we want them to approve. And you know, it's talking to this group, and here's the servers behind it. I know this is busy, and it maps more to my internal architecture, but it was a way for us to visualize something that was very complicated in a spreadsheet. Like if you got this table of rows and information of servers and endpoints and things, it was a lot of tedious work for them to figure out what was really behind it. But we were able to say, you know what, take a peek at this. Does this look and feel right and normal? And when you see these for every service, you know, nuances, outliers jump out at you a lot easier than they would otherwise. And then our F5, our load balancer. I don't know if you're doing load balancer configurations, but here I know the wide IP to the GTM pool, to the pool members, to the virtual servers across 2 data centers here. And I've got a pool on Austin versus LAX. And then here's the node members and the actual servers behind them. like here's this beautiful diagram of the whole stack of a request coming in and the IP addresses and the devices of every step of the way. Like that was another one of those things that, you know, it was annoying to look at in a spreadsheet, but being able to visualize it. And you see these boxes are green. Like I was actually testing configuration drift on this as well. So if it didn't match what I expected the configuration to be, I'd have a little red box there for somebody to actually go investigate why it's out of compliance, if you will. And then, I don't know if it matters, but like this guy here, this virtual server in the middle, he's actually just a port 80 redirect to 443. But just, it's kind of cool how some of this data just shows these unique patterns to it. All right. So let's graph some other complicated stuff. I've already mentioned PSGraph Plus. Like these are the 2 demo graphs I had before. But I can also do some diagrams of Git, because Git is really just a directional graph, if you think about it. So if I run this from my current repository right here, you know, I know there's lots of ways to take a look at what graph Git has, but for this, I'm like, hey, here is all the commits and the messages I've made to this repo for this presentation. If I scroll up a little bit, like here's what I've got on the gallery right now, so I do need to, actually take it back. Here's my master branch, and I forked it for this talk. This commit here is the one, so in the PS Summit 2019 is where this presentation currently lives, and I've got 2 local changes I haven't pushed yet. And I can see that really cleanly here. And I've used this to troubleshoot some weird scenarios. If I take a look at another module, my PSGraph, you know, like here's a case where I had like a feature branch that was kind of long-lived that I finally got merged in, and you know where the branches were before that merge happened, and I can see the comments along the way. You can get some really pretty cool things when you're looking at some projects. Then what, the PowerShell repo, like they do a lot of merge commits or squash commits, so it looks like this nice pretty graph. And then who else here? And I've got the PowerShell get, because theirs isn't as pretty as PowerShell. Which, nothing spectacular, but just more this flow of like, I've got this complicated thing and I want to diagram it in a way that makes more sense and easy for me to look at. So I'm trying to inspire you to show like what's possible, like where you could take something like this if your imagination could kind of just like go with it. And then, oh man, we could do like graphs of PowerShell modules. Like if I want to see what functions this module calls, I can have a diagram of PSGraph of what PSGraph contains. So here is, like on the left, the core of PSGraph, and on the right, like my helper functions to make sure I can export these graphs cleanly. And I can map multiple calls to see how many times I call different functions as a feature. And so we're kind of running along on time here, so I'm going to jump to a little AST parsing, because everybody loves the complexity of the AST. You know, if you've ever had to look at that and thought, boy, is this a monster. But here I took that script block and actually just walked it and diagrammed it as just a way to see the flow of the logic. And it's interesting, if I run that on some of my developers, at a high level, like some of the complex scripts, you can actually see patterns. They can almost say, oh, I know who wrote that one, I know who wrote that one, based off the flow of their diagrams, like almost like a fingerprint. And now if you are truly working with the AST, actually, I think I got a more complicated one here, real quick. The show AST graph of just a, where are we at? There we go. Here's an actual command of mine. I mean, it's a lot to take in. Like, it really isn't realistic to use this to do any complicated script flow, right? But it's kind of a cool proof of concept that I can take something complicated and see pieces of it. And even the parameters, you know, gets broken out. So I have a parameter of seconds and show changes and things like that. So it's pretty cool stuff in there. All right, and the last graph here is I'm actually taking this first script block here, this one with this right verbose and this error. And if you are having to work with the AST, God forbid, I have this command for showgraph annotate that will actually explode it and show you all of the AST actual abstract registry objects and annotate them directly. So here, I can see this right error is actually a string constant expression, a command AST, and a pipeline AST right here that then have these two parameter blocks. So if you're doing like script analyzer type stuff, this might be just a handy tool to have. All right, so with that, demo. On my website, PowerShellExplained.com, I've got actually several posts on these features that could probably walk through probably a little more slower. I know I ran through a lot of pieces really fast because I generally do this talk in like an hour 20, and I kind of like customize and pull some things out that, and then added some new stuff just for the audience here. And then with that, I suppose I'll take your questions and we kind of discuss, what ideas you guys might have for using PSGraph. Well, hopefully you guys can find some good uses for it. I mean, if you do create some Google Graphs, feel free to tweet them my way or share them. I'd love to see what you guys can do with this stuff. And if you have any questions, I'll be around. Thank you.